When I get older, losing my hair many years from now, will you still be sending me a Valentine? Birthday greetings, bottle of wine. If I'd been out till 2:45, would you lock the door? Will you still need me? Will you still feed me when I'm 64?
Hi everybody, this is Dr. Ed Park. We're going to talk about hair today, and I want to thank everybody for joining in. So we're running a little late because we had a visitor from Canada, very interesting fellow, and we just got to talking about ancient Rome and Greece and early Christianity, so that really is an interesting topic to me. Speaking of origins, let's talk about the origins of hair. Some of you might believe in evolution. I do believe in it. I don't think that's mutually exclusive with faith, but this theory holds that we evolved from these original ancestor. The protists, or the bacteria, came off here, and then we invented symbiogenesis, which was these little bacteria got incorporated into protozoans like amoebas, and then the eukaryote was born, one nucleus, and then a bunch of little power plants. This diverged into plants here, the chloroplasts. They got these green mitochondria, you might say, that photosynthesize. And so anyway, let's move on down the branches here. We got the sponges, the jellyfish, the insects. Here is the vertebrates, and here is the invention of hair. So on this branch, birds, dinosaurs, iguanas, snakes, no hair. On this side, we got hair. So we got marsupials, koalas, chimps, humans, cows, whales. Whales have hair. Some people think that baldness is a selected trait, which, I majored in biological anthropology, which is the origins of man, and even to me that doesn't really pass the smell test. Apparently they thought that I could see a silver back, but a bald head is apparently something that fertile females want to mate with. I think that's probably not a great theory, but I could be wrong. By that measure, then, a pot belly and also wrinkles should be a competitive mating advantage. I believe, as I hope you will by the end, that baldness is just aging. So, what is hair? It's mainly made of this tough stuff called keratin, and the only thing close to this toughness would be chitin, which is the stuff that is the shell of insects and other arthropods like lobsters. There's a sebaceous gland which secretes sweat, which is amazingly efficient at temperature regulation. There's the erector pili muscle, which is not shown here. It's like a little tent stake tether, which can cause the hair to stand on end. And of course, that's innervated. It's something that, if you think about some movie like The Shining or a Hitchcock movie, they'll all stand up at once. There's a sympathetic nervous system. Is the bulb, the matrix, and the papilla. That's the root here, if you will. So the bulb is surrounded by this cellular matrix, hair follicle matrix, and there's something called dermal papilla, which invaginates. This layer is the dermis. Above it is the epidermis. So this little invagination is a dermal papilla. So this will cause the growth of the hair follicle. You get these things called trichocytes, which are hair cells, and melanocytes, which are pigment-producing cells, and they all dwell in this area. Right here is the bulge. The bulge is where these stem cells reside, and this is where the trichocytes and melanocytes are generated from. So if you pull your hair, pluck it, it dies naturally or is poisoned by chemo. Our hope is that the cells in the bulge are intact enough to reseed, if you will, and regrow the hair. I used to practice OBGYN, and in doing so, you always hear the complaint that my hair is falling out, doc, about 3 months after the delivery. This is a result of synchronization of the hair. It's not that more hair is falling out per se, it's just that it's all timed the same, and that's caused because of the massive doses of hormones of pregnancy. Similarly,
Hair can be synchronized by stressful events or by massive death, as which comes with chemotherapy. Usually, the hair is staggered in its growth and death, like these fields shown in the upper right. Some fields might be lying fallow and resting to recover their nutrients, others growing wheat, barley, sorghum, etc. So similarly, hair throughout the body is in different staggered stages of growth and resting. The growth phase is called anagen for growing, like anabolic, and this determines the length of the hair. Head hair has a long anagen cycle, up to 8 years, so it can grow very long, like Cher, whereas the hair on your arm generally has a very short growth cycle and spends the majority of its time in telogen, or the resting phase. So we see that hairs transition through growth, which determines their length, a transition phase called catagen, and then telogen, telo meaning end, like telomere is the end body, telogen is the end phase, where it rests. And in this time, if you pluck it, it won't grow back immediately, presumably. When we have chemotherapy, we're globally destroying all stem cells and hoping for the best. And an unfortunate consequence, but a logical one, is that all the stem cells in the bulges throughout the body are killed, and we hope that they are replaced. In a bald person, what has happened is that the bulge cells have copied and copied, and they've burnt out to the point which they're no longer viable, and that usually is not coming back. This interesting chart shows why it's hard to remove certain types of body hair. If the hair is only growing 10% of the time, and the growth period is only 6 weeks, there's a very unlikely chance that the follicle goes down to the dermal papilla, where it can be used as a conductor to destroy that dermal papilla, and also the bulge cells. So that's why you have to do multiple low probability attacks with, laser hair removal. Of course, the longest growth and the most actively growing would be the chin, so the beard can get rather long, although not as long as the head hair, which is actively growing 80% of the time and would have a duration of up to 8 years.
Interesting fun facts about body hair. There's about 100,000 hairs on the head and 5 million on your body. Most of them are growing. Some of them are in the fallow resting telogen phase. Hair grows at about this rate per day, this rate in the body per day, and the hair follicular density goes down as we get older. At birth, it's 1,100 per cubic or per square centimeter. By a year, it's 800, 15 years. So you become progressively hair less, even though the hair may get thicker, obviously, after puberty. Certain areas of the body don't have hair. That's called glabrous skin, notably in the fingers, in the palms, in the glans penis. And the second type of hair would be lanugo, a kind of fine woolly hair that happens in late gestation, perhaps because as ontogeny recapitulates phylogeny, so the growing embryo and fetus goes through evolutionary stages, if you believe in that sort of thing. So a vestigial tail will go away, etc. Could be that a recent primate ancestor was covered in more body hair, hence fetuses have that. Most of the hair on our bodies are terminal or androgenic hair. So let's look at the patterns here. This gent here has a beard, chest hair. This is the hair down the belly button and in the genital region. Inner or the thighs, lower legs, arms. This is male pattern hair. And of course, there's some androgenic effects in men as well, unless you have something like testicular feminization, where there's no responsiveness to male hormones. So you do have some hair distribution. It serves a function of temperature regulation, secreting sex hormones, pheromones. And again, to recap, the body is a very short growth cycle, so the hair remains relatively short. Face is longer, so it can get pretty long, but the head hair grows for 8 years before it dies out, so you can get these long, wonderful. This is a young man, I don't know, probably 8, 9 years old, and what we see is that he appears to be an old man, and he does not have a lot of hair. This looks like a gentleman with balding. I mean, if you were to cut off this and just look, you wouldn't guess this was an 8-year-old. This argues to the point that aging causes hair loss. Progeria means towards oldness, so it's the premature aging syndromes, and they all involve damage to the DNA, in my opinion. Here at the bottom, telomeres are not shortened, so you have one that's due to the winding and unwinding hormone, the helicase. Bloom syndrome. There's problems with DNA transcription or copying and rewriting DNA. That can be xeroderma pigmentosum. Again, derma being the phenomenological name for this, there's something wrong with the skin. Trichothiodystrophy, the nails don't grow. This is a sulfur processing issue. Cockayne syndrome. Ehlers-Danlos is more of a collagen. There's a progeroid form. So something's wrong with the matrix of the cells, and these are the bendy fingers, like the almost like Marfan's, tall people. Anyway, the telomeres don't have to shorten. This is a way to get DNA damage or matrix damage, and you get prematurely old. But the more classic progerias are above here, the telomere shortening progerias. And so let's look here. Two of the, in red, the ataxia telangiectasia and Nijmegen breakage syndrome. You get these funny capheo lay spots, and you get some odd phenomenon of the eyes. But you get graying of the hair. Now, when the feature of alopecia, which is baldness, and nail disc growth and osteoporosis comes on, we have a rapid deterioration of these stem cells, creating the hair, the nails, and the bones. Helicase deficiency is prominent in these two, and then the classic is dyskeratosis congenita, of which they say there's an X-linked version and autosomal dominant version. The description is congenita, you're born with it, and dyskeratosis, the keratin-containing structures are messed up. Drilling down a little deeper into dyskeratosis congenita, this poor little fella, probably about 11 years old, he'll experience baldness, precancerous lesions in the mouth called leukoplakia, bad nails, which is a good correlation for one's age, strange pigmentation, lung fibrosis, liver cirrhosis, intestinal problems, failure of the testes, and failure to produce bone cells or blood cells. So myelodystrophy is a quote-unquote idiopathic disease. It's probably just aging of the hematopoietic stem cells.
So what causes dyskeratosis congenita? Well, it turns out that we're usually born with 2 copies of a good dyskerin gene. Dyskerin is the molecule to the right here, which is where the green corkscrew is bound. And this serves as like the keyhole for the telomerase key. So on the left is the end of a chromosome, and the big colorful rainbow blob is the telomerase engine, which will pump out more telomere ends, but only if the corkscrew end of the key, the green template, fits the dyskerin keyhole. When you have dyskeratosis congenita, one of the more common forms of this uncommon disease is that the dyskerin gene is only a single copy. So when you lose the only remaining good copy, you have no way to lengthen the telomeres. So if we think of genes as dosage, a single copy of dyskerin gene gives us a life expectancy of 11. 2 healthy copies gives us a life expectancy of around 80.
So moving right along, here's a study from the British Journal of Dermatology in 2004. It's merely saying that graying is caused by dysfunction and the death of the melanocytes. If you're somewhat damaged, you got a gray hair. If you're totally damaged, you got a white hair. And interestingly, we think of blonde hair as something very uh, unique, but practically speaking, it's just the lesser production of melanin. It's not necessarily a different color, although human hair color is a very strange and complicated topic. If you damage the genes and the melanocytes, it triggers their differentiation. So as we have covered in the past, podcast 5, when a stem cell differentiates, it no longer becomes a stem cell, or it becomes less stem-like. So the two characteristics of stemness are immortality, which is directly correlated with telomerase activity, and asymmetric division, meaning it doesn't make two daughters, it makes one clone mother and one daughter. So it reproduces itself and makes a little more differentiated daughter. So as the DNA damage accumulates, these melanocytes differentiate, which means that the days are numbered for that cell. TGF beta has been implicated, transforming growth factor beta has been implicated in hair growth, and it appears that this is somehow involved with signaling the arrest of the cell cycle. This merely brings up the point that TGF beta is involved maybe by a separate pathway with the famous p53 that we always talk about apoptosis. So this is all involved. I would focus here, if I was spending research money, I would stop looking at the whole issue of testosterone and male pattern baldness, because that's a dry hole, so to speak. So if you ask the wrong question, you get the wrong answer. So garbage in, garbage out, or keep it simple, stupid. So if I ask, well, what kind of cheese is the moon made of? Well, that's really, I'm not going to get a good answer, because the moon is not made of cheese. So similarly, we're looking at the activity of telomerase. I mean, it's not a stupid question to ask, but they looked in the study at old skin, people with sun-damaged skin, people with one of those premature aging diseases, xeroderma pigmentosum, and 40 quote-unquote normal groups. And what they found was that the photo-aged and the premature age showed greater telomerase expression than the younger. So they're concluding that the telomerase expression is causing the aging. But then they go and make the right conclusion by saying telomeres rather than telomerase are involved in cellular senescence. So you can make the best experiment observation in the world, but if you're trying to editorialize, extrapolate, and explain, and God forbid add an evolutionary explanation, you're probably going to come up with some crazy ideas. So my theory about this is a little simpler. I try and keep it simple. And so I say that telomerase is upregulated when you begin to have damage to stem cells. So what happens is the skin is damaged, so the telomeres are trying to be lengthened to rescue this from senescence and cell death. And I think that explains some of the occasional studies you'll see in cancer or aging cells. Well, they'll say, oh my God, telomerase is active. Oh my God, telomeres are long, in these damaged cells. Hence, the telomerase and the long telomeres cause the disease. Well, this is tantamount to blaming the firemen for the fire. So you're saying, well, God, there's these guys in yellow plastic jumpsuits who show up, and so they must be causing all these fires, so we have to kill the firemen. Again, ask the wrong question, you get the wrong answer. And so what we see is that when you get early stage cancer or disease in any of these organs, the telomeres shorten to the point of damage, and then the telomerase kicks in as a salvage mechanism. And then if you do a late study of breast cancer or whatever cancer, you will find aberrants. You'll find extremely long, because the one way that the cell had to repair was to lengthen the telomeres, so you'll get incredibly long telomeres, but it's too late. The horse is already out of the barn, so to speak, and lengthening a bunch of damaged and aberrant aneuploid chromosome not going to help. But then people will just, conclude what they're going to conclude. This is an interesting study by Blasco out of 2006, and so what she did was to map out the length of the chromosomes. Now, this is messed up because green should be good, right, and red should be bad, but it's inverted here. So let's look at the hair bulge and bulb. This is where you want your stem-like cells to replenish. So wild type means normal and diseased, and this is the first generation of TERK negative negative. This means that there's no key to run the telomerase engine. So these telomeres are going to shorten rapidly. These are mice that have been engineered to age rapidly. So what we find is if you can't run telomerase, that you get much more greenness in the bulb. And so what does that mean? It means that they're aged. They're shorter telomeres. You want the red and orange. So in a normal wild-type hair bulb, you can map out, and the telomeres are long here. They're healthy. Whereas you see more green, which is bad in this case, in the aged telomerase incompetent. So what they're doing here is a technology that would eventually evolve into the life length test. So they're mapping literally in one hair where the short telomeres are. This is my result from January of my telomeres. These are white blood cell telomeres, and it's literally painting every one of those and then quantifying how many of them are damaged and what the average length is. So this is my results show that I have a lot of red and not much green. So only 10% of my telomeres are less than 3,000 base pairs. So that's quite good. That would be correlated to more like a teenager. Why is this important? Because remember that a stem cell is like a queen bee, and all of the drones and clones around her are copies. So when you have a very aged hair bulb here, all the cells that come from the queen bee are going to be just as old and damaged as she. So that, I believe, is the process that we're looking at in all hair loss, as well as loss of pigmentation or graying. Now, telomerase will regrow hair without regrowing the telomeres. So what does that mean? These folks out of, I think, Stanford in 2005 said, let's do an experiment. And I like it because they didn't really know what they were looking for, so it was a pure experiment. And what they did was they engineered these knockout mice. Again, TERK means there's no RNA component. There's no key to run the engine. So they don't really effectively lengthen their telomeres. So every generation will become older than the next. So they engineered these TERK negative mice to have increased telomerase reverse transcriptase. That's the engine, not the key. The TERK is the key. They turned on the engine, and even in the absence of a key, the engine alone caused follicular growth. So if you had an engine and one copy of the key, you had more. And if you had an engine and introduced double copy on each chromosome of the key, you had a lot of hair growth. So what they were most interested in is that in this quadrant you have no key, so no effective lengthening of the telomeres ends, but the telomerase itself somehow managed to restore hair follicles. And so that's what we call N1 or non-canonical. Anyway, it just means that it's not the typical role we think of telomerase as a reverse transcriptase or turning RNA template into lengthening DNA. And then there's also an N2 non-canonical telomerase role, which just means that you don't need telomerase or the telomerase RNA component to have an effect. So what did we witness with these mice here? If you didn't have the transgenic modification or introduce the new genes, you got the naked mouse butt here. If you didn't activate it, you're still naked, but if you turn on the reverse transcriptase, even in the absence of the RNA template or the key, you got new hair growth. This slide is entitled Of Mice But Not Men, and again we talk about the phylogeny. The mice got hair, the chimp got hair, the boy got hair, so we all got hair. So if you look at the actual components of the RNA, they're identical, which will come into play later when you look at the dog model. So what gained us a lot of attention in new patients was this study out of Harvard Medical School, Dana-Farber Cancer Institute by DePinno, where they introduced the reverse transcriptase, again that engine, into aging mice, and they had a key, a separate key, which was similar to the tamoxifen model, so they were able to turn it on at will. And what they found out, lo and behold, was that the mice got younger. They got less gray and healthier, and so everyone got excited, and the mainstream media picked it up for a while, that mice could be made younger by activating telomerase. Actually, these are artificially aged or aging mice. So people thought, well, gee, maybe someday we'll be able to do that with people. Of course, this is long after people have been taking it, such as myself, since 2007 or even 2005. A second, pretty much identical study would be from Blasco, when she actually last year published that she took TA65 and, again, with these knockout mice, introduced it, and it made them younger. So telomerase reintroduction or the increased expression caused the hair to get younger. This slide is entitled Where the Rubber Meets the Retread. And this is really the most interesting study, and this is really probably the reason, other than the white papers that TA Sciences gave me, why I decided to take this. As we discussed a little bit in the brain cancer webinar, my father had brain cancer, so it led me to try and look into why people got old and aged. And this study showed that telomerase activation actually rid the body of these damaged cell types. So we've talked many times on these webinars about how chromosomes become damaged. Essentially, the ends become so short that they are recognized as damaged, and they get spliced where they don't belong. And when you next time you pull the cells apart, or excuse me, the chromosomes apart at the anaphase bridge, they'll get ripped apart into confetti. So here's the confetti. There's signal-free ends, rings, little donuts, end-to-end fusions, which are like the two trapeze artists, and fragments. This is all just cutting the calamari or the little, it's bad. And this is what happens in every cell, and that's fine if it's a non-stem cell. But if it's a stem cell, then you get into real disease because those are already immortal by virtue of telomerase. So the introduction of functional telomerase activity effectively eradicated these genetic abnormalities. So in these mice, they got bigger and healthier, and the hair got better just by reintroducing the key to the lock. So these histograms show this has to be basically apoptosis. The damaged cells are able to go away. And that may be the N1 non-canonical reason that you're doing something to allow the cell to go through its final stage of apoptosis. It doesn't necessarily mean that you're lengthening the telomeres significantly. It just means they're long enough to get that final screw out or to kill it. So I liken it to a retread because every tire will get bald, but you can retread it. And so that may involve actually killing off some of the damaged stem cells and being replaced, but that's uncertain. All right, let's have some fun now because that science is pretty dry. So let's listen. You're going to have to say yes to sharing screen. And then the first case is Ben and Bill, who were featured in podcast 21, identical twins.
So you got the hairy arms here? I don't really see that. So you're saying that this hair, it is thick, isn't it?
Well, it's long. He's got these. He's been braiding these up here.
Yeah. And it wasn't as dark, you're saying?
There was no dark.
No, I've never had hair.
But you don't have the werewolf thing happening.
Well, I do. For me, I mean,
not much.
It's more downy, though. I thought you guys were identical.
No, well, we were, but
we were.
His is growing. His is going down. It's changing.
Okay. So that's good.
That is good.
What I've noticed is some amazing things, actually. I was in a really bad accident in '97, and I lost a fair amount of my hair, especially on this side and in the back. And I would say after into the second month, I noticed that I was growing like a second level or third level of bangs. That's the best way I could.
Yeah, I see that.
I could describe it.
Curly, like when you were a baby?
Exactly. It's coming in very curly. When I was a little girl, I had ringlet curly hair.
I see that here.
Yeah. In fact, I think it's coming in even thicker. There's even a shorter bang coming in. I mean, you can see it. It's in layers.
Yeah, I do.
And it's coming in like a complete pin curl.
That's so cool.
Very cool. So that must indicate, to my understanding, which I could be totally wrong, but it must be that it's rebuilding my telomeres with the initial DNA blueprint of when I was a child.
Yeah, well, a lot of those cells were in a state of arrest.
Yeah.
And so you may have reactivated them or killed them off and they were replaced. I'm not sure exactly. So how old are you now, Billy?
I'm 68.
68. Oh, so you guys are friends to the same age.
Yes.
So good. So tell me where the hair is coming up here.
Oh, the hair is coming right here. And
So in the temple,
in the temple,
you have this fine
which I didn't have before.
black hair.
Yes, it's dark brown.
Oh, right here. Yeah.
And it's growing more and more. In other words, the pieces didn't stop growing. They started coming out, and then they just proceeded. And also, I don't lose hair in the shower when I wash my hair like I did prior.
At least a year and a half, going on 2 years.
Yeah. So initially, well, how old are you, first of all?
70.
70. And I remember you called initially right after starting. You said your hair was getting darker. Was that?
Yes, that's correct.
Did
Yes.
other people comment on
thicker.
that?
Yeah. So, yeah, I think people kind of notice. Some of the changes are relatively subtle too. But yes, and I can tell there's some new growth. Actually, the areas, the thinner areas are getting less pronounced. That is, that they're filling in.
And so at the temples, is it starting to come back a little bit? The hairline?
Yeah, it's coming up more in the center.
Okay. Interesting. So that's something that didn't happen overnight, just gradual over the last 18 months?
Correct. Yeah, it's happened probably over the last 8 months.
Oh, so it was really it was the first 8 months there was not much then?
Yeah, I didn't really know. It seemed, I don't know if it's accelerating, but I can see that it, I think what happens is over time, you all of a sudden you look at it and say, oh my gosh, this is filled in. So you don't see it, until you really look at it, and then you say, my goodness, there's quite a difference.
So you said your hair was different now?
I think so. My hair is a little bit
You're
darker.
saying,
Yeah, I got some more
I'm going to
dark
look
hair.
here. Was it all gray before?
Yeah.
So what is it now?
Now I got a little bit black.
Oh, yeah.
Some black. Yeah. That's,
Quite a bit of black there, huh?
yeah.
Wow. How about the amount of hair you're getting?
I have the same look.
Same,
I
yeah.
haven't seen them. I don't know. Just gonna go.
I'm going to take this, okay?
Yeah.
Tell me who you are.
I'm Luis.
Luis and
Raquel.
Espinosa. But the granddaughter, maternally, your mom is Armida.
Yes.
And your mom's mom is?
Soledad.
Right.
Yes.
So we gave her the TA for like a week or a couple days.
I'm not sure for how long, but my mom did notice, and if you go and stand over there, you're gonna see she has some strands that are black. She started getting black hair.
Like the here, the roots. Not so much the ends. The ends are still
but
kind of
some
white.
strands are black.
So she's had white hair for many years then?
Yes,
Oh,
years. And all of a sudden, I walked in one day and she's eating dinner, and I looked at her and I could see little black spots.
So you noticed it too, Luis?
I noticed it right away.
Really? Let's go check it out.
No, you can see it from up
But
here.
I was
You can
told-
actually see it from here.
I was told that her ulcer went away.
Look at the strands. Look at the strands.
Oh, yeah, mira.
It's all white, and you can see a little bit of black.
Oh, you're right. Oh, my God. Look at that. Está saliendo pelito negro. Chido. Look at all this.
Mucho, miren. Y aquí más, se le ve más aquí, miren.
So apparently 112 years of aging is not irreversible when it comes to hair follicles, so I have to adjust my understanding. It's hard to follow that act, 112. And so I'll take questions now, if anybody has any questions. Hi, David?
How you doing?
Oh, it is David. I guessed well. Okay. Good. How are you?
I'm alive and well.
Still living. A good thing it's not killing you, because I talked to Jerry and Naomi on the arthritis webinar. They're 88. They've been taking it since '07 and doing great, living the life. So hopefully it's not killing them. They're 88. So how are you doing? You're 49 now?
I will be 49 next week, yes.
Oh, happy birthday. So how do you feel?
Actually, 2 weeks. 2 weeks. The 28th I'll be.
Great. So you've been on it for almost a year now, or?
Yeah, just under a year.
How's it going?
It's going great. I'm much more interested in what's going to happen in 5, 10, 20 years because the thing that I'm intrigued by is the fact the critically short telomeres are the ones that are being built up. I'm not so concerned about getting older because I'm able to run. I'm able to. The only real effect of aging that I've experienced is weight gain and salt and pepper hair, which that's why I tuned into this show because I have noticed that my hair is starting to get darker again.
Really?
I can't put a finger on it, but the women in my life have commented on it. They specifically said that the pieces of gray hair are turning more of a light brown. That's why I was really curious about Soledad with how it was affecting her. And she looks remarkably good for being a super centenarian.
I tell you what, yeah, 110 super centenarian. You know, Sophia, who's called it a couple of times, her husband did a documentary for the Nixon administration about people who lived past 100. They found only one common denominator that they all had was a sense of humor. So I know that Soledad is a big joker. She just teases everyone, and sometimes it's just, you know, she talks like a truck driver and she sings. So I think there's something to that. Just very alert. Thanks for sharing.
You mentioned about. I did want to mention something. You mentioned about the how hair evolved. And, as I'm sure you know, I was an anthropology major when I was young and impressionable, and there was quite a bit of talk that Carl Sauer raised about the aquatic ape hypothesis, and that essentially the loss of fur was a result of an aquatic adaptation on the African coast. It's an alternative theory not accepted by many serious anthropologists other than me, but it's an interesting theory because it also explains things like the shape of female breasts and how they float in the water and so forth. And specifically, it points to the fact that women's hair, it's a sexually characteristic because the women are going to be the ones that are caring for the child in the water, and the child can grab the hair and hold on to it.
This is wonderful stuff. Wow.
You've never heard that?
There was that book, The Naked Ape. Yeah, it's fun to make up stories when there's no way to check the facts. So I guess in that scenario, evolutionarily speaking, Ginger was more suitable mate than Marianne.
Well, I don't know. Marianne had the ponytail, so you know the children would be able to grab onto the ponytail. Yeah,
Ginger could have stayed afloat longer, though. But anyway, we should probably move off this topic. Yeah. Okay. Thanks.
All right. Have a good one.
All right. See you, bud. Thanks. Okay, question here. Dwayne to everyone. When people reach their 40s, there are often vertical ridge lines that devil the nails. Has anyone said that these lines go away with T65? Yeah, it's been my experience that they do go away, and that's a good question. And going back to the progerias, realize, of course, that these things all have phenomenological names, like dyskeratosis and, well, some of them do, xeroderma, trichothiodystrophy. Yeah, that's bad nails because the nails get ridges, and certainly I think that's a direct correlate. If you plot out nail growth and health, nothing gets better after 25. So if you want to avoid baldness, probably the best is to have a high activity of telomerase, or at least one that can keep you from losing telomere length. Starting between 20 and 25 would be the best. But I would think that no amount of telomerase activation is really a bad thing. I'm still waiting to understand that mechanism. Any reports on T65 removing keratosis lesions? Yeah, I hear that a lot. These dyskeratosis lesions go away. Although moles can get darker. Did your friend's father decide to stay on a TA after the good scan of his brain? I think he's leaning away from that. They have golf dues to pay. And so, you know, I was talking to my friend, and hopefully we can get him to reconsider that. But I do believe he's pretty much cured at this point. We'll have to see. But 4.5 years out from diffuse brain cancers is not usually the case to have a clean MRI. What about thinning? Dwight asks, what about hair thinning with a thyroid condition? No, thyroid needs to be treated with thyroid, and that's a universal hormone for every cell. People that think that they can get away without thyroid hormone are grossly mistaken. That's like the temperature regulation. And I have seen changes in thyroid function, both recovery and less function. So again, another one of the myriad of reasons to don't just buy this out of a vending machine or from GNC. You work with a doctor who can guide you. So I think that there's nothing good about aging, and there's nothing good about hair loss, and that it really represents an abnormality, and the system is very abundant and is made to regenerate hair forever. Witness the 5,000-year-old trees. So life is a very resilient and renewing resource, and that we really need to view things like cancer and aging as abnormal, difficult to achieve, and totally voluntary. So let's hope for that kind of paradigm shift. All right, everybody. Well, Susie asks, I've taken it for 4 years. What have I noticed? You know, when I initially started, I got a lot of hair on my chest, like a teen wolf. And I just think that was a hormone surge and a recruitment, simultaneous recruitment, because over time my hair is the same. So it's just a recruitment phenomenon. Like all those hair follicles got reawoken right about the same time. But over the course of time, my body hair distribution, everything is the same. I would say that my hair has had the tendency to go into telogen effluvium, which is that it won't fall out at all for like 10 weeks, and then for 1 or 2 weeks, I feel like I'm really thinning out. So you do get some synchronization of the telogens, but usually hair loss is not noticeable because it is staggered. Again, the fields are fallow at different times, but I would say it does tend towards synchronization of hair loss. So every once in a while you'll feel like you're losing your hair, but then the rest of the time you won't notice it. It'll be really thick. But I think the hair quality is very good. I mean, you can kind of see me in this picture for 45. There's no bald patches or recession or anything. There's no gray at all, so that's pretty decent. Although my mom has pretty good hair. She's 75. She doesn't really dye her hair. It's still very, very white and gray, but she's got pretty... Actually, what am I saying? No, she was wearing a wig a couple of years ago. Sorry, Mom. No, it really had thinned out, but then she's got a very stressful lifestyle, too, so... Yeah, I'm 45. Okay, thanks a lot. Bye, everybody.
Give me your answer, fill in the form, mine forevermore. Will you still need me? Will you still feed me when I'm 64? Woo!